Assalamualaikum warahmatullahi wabarakatuh. My name is Afiuddin, and my partner and I will present an assignment about material of future. And the material we choose is carbon nanotubes. So let's proceed. What is carbon nanotubes? So carbon nanotubes are cylindrical molecules that consist of roll-up sheets of single-layer carbon atoms or graphene. They can be single wall or short term. In this presentation, I will say it's SWCNT, which with a diameter of less than 1 nanometer, or multi-wall, which is MWCNT, consisting of several concentrically interlinked nanotubes with diameter reaching more than 100 nanometer. CNTs or carbon nanotubes are chemically bonded with sp2 bonds, an extremely strong form of molecular interaction. This feature combined with carbon nanotubes, which is in natural inclination to rope together via van der Waals forces. So this is an example of the carbon nanotubes. So at the figure at the right side, that is a single wall carbon nanotube, and the left side is multi-wall carbon nanotube. So this is the structure of the carbon nanotubes. So next is what is why the carbon nanotubes is suitable for futuristic application. There is several um, characteristic, which is first is electrical conductivity. So their conductivity has been shown to be a function of their clarity, which is degree of twist, as well as their diameter. Carbon nanotubes can be either metallic or semiconducting in their electrical behavior, and some types of armchair structure carbon nanotubes appear to conduct better than other metallic carbon nanotubes. It has been reported that individual single wall nanotubes contain defects which allow the structure to act as transistor. Likewise, joining carbon nanotubes together may form transistor-like devices. Other than that, the characteristic which is strength and elasticity. So the carbon atoms of single, which in graphene sheet of graphite form a planar honeycomb lattice in which each atom is connected via a strong chemical bond of three neighboring atoms. For this, we can see at first at previous slide, which is the structure of the carbon nanotubes, and the basal plane elastic modules of graphite is one of the largest of any known materials, and single wall nanotubes are stiffer than steel and very resistant to damage from physical forces, which is when pressing on tip of a nanotube, it will cause the nanotube bend, but without damage to the tip. When the force is removed, the tip will return to its original state. And this and the figure at the bottom, as we can see, that is the under microscopic observation. Next is thermal conductivity and expansion. So for carbon nanotubes, the strong in-plane graphitic carbon-carbon bonds make them exceptionally strong and stiff against axial strains, and the almost zero in-plane thermal expansion but large interplane expansion of single wall implies strong in-plane coupling and high flexibility against non-Asian strains. And last one is high aspect ratio. So the carbon nanotubes represent a very small high aspect ratio conductive additive for plastic of all types. Lower loading, which in terms of concentration of carbon nanotubes, is needed compared to other conductive additives to achieve the same electrical conductivity. This low loading preserves more of the polymerization toughness, especially at low temperatures, as well as maintaining other key performance properties of the matrix resin. Their high aspect ratio around thousand in one imparts electrical conductivity at lower loadings compared to conventional additive materials such as carbon black, chopped carbon fiber, or stainless steel.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to Dr. Siti Haida. My name is Don Azriza Rahimi bin Asman, and I'm going to present about the current method versus the use of carbon nanotube in some application. Firstly, we will focus on the first application in carbon nanotube, which is the desalination. So this process is the purification of water from its salt and the mineral components, where thermal distillation, reverse osmosis, and electrolysis are used. Among these methods, the reverse osmosis is most commonly used and accounts for 60% of the global desalination capacity. So in that picture, we can see that this is the desalination plant where you use the reverse osmosis process in the Barcelona, Spain. So the current method of the reverse osmosis is it purifies the salt water by forcing it through a semi-permeable membrane, which require large amount of energy. The operating pressure has to be increased with the rise of the salt concentration of the feed solution. Thus, the high volume of salt water is wasted to avoid the overpressurization that could cause the malfunction of the membrane. This process is not only remove salt from water, but also filter the healthy minerals. Thus, the quality of water obtained is lower and make it less suitable for drinking purpose. So the CNT actually can replace this old-fashioned technique. How it would actually? So the CNT contain the positive NH3 plus and negative CO minus functional groups. These functional groups are very hydrophilic and they can attract the water molecule to the opening of the tube. The CNT itself is very hydrophobic, that causes the water to flow through very quickly because of the repulsion from the wall of the CNT. So in the process, the dissolved salt, mainly in the form of cation, such as the sodium ion, and the anion, such as the chloride ion, are captured by the functional group to the electrostatic attraction between oppositely charged ions. So finally, the saline water is purified by the CNTs by the rejection of the salt pollutant. So is there any good if we using the CNT in the process? Of course, yes. Firstly, the frictionless property of CNT allow extremely rapid water flow, making the process more efficient with much less energy needed. Secondly, The combination of CNTs with membrane distillation can increase the water recovery to nearly 100%. In addition, it selectively captures unwanted salt and retain the beneficial minerals by adjusting the ratio of the functional groups that exhibit higher affinity with the specific ion on CNT. CNT are even capable of self-regenerating. So if the structure are damaged by the external issue, they can go back. And finally, they can kill the microbes to prevent the damaging of its surface. Next application is anti-icing, which I focus in the implant. Anti-icing, also known as de-icing. This process is the removal of any frozen or semi-frozen moisture from the engine intakes and fan blades and protection of external surfaces for subsequent contamination prior to takeoff. So, from the picture, this is an example of the anti-icing process on aircraft, but this method is on another type de-icing, which is on-ground de-icing, where it uses the propylene glycol to remove the ice. So the current method is actually there are many methods which is in implant anti-icing system, such as the pneumatic, electric, and air system. So in general, when a plane travels through clouds in a cold weather, the layer of ice can form on its wing, propeller, or jet intakes that increasing the drag and reducing the lift. This will causes loss of control for the plane. The conventional passenger aircraft anti-icing system divert a portion of hot air from the engine and pipe it to the wing surface. The heat transfer to the outer surface by the thermal condition will stop the ice. However, the system is actually adding the weight and the maintenance requirement where it is not energy efficient. So by replacing them with the CNT is actually beneficial. How? So a team of experts from the Queen University Belfast developed an ultraweight heater, which is a CNT web. So how it's made? The individual CNT are aligned in the draw direction and horizontally, stacking 10 to 40 layers of webs at a different orientation to achieve the desired heating features. So we also tune within a thin glass fiber laminate to provide the structural support and connected to a power supply. As a result, the developed CNT web achieve the rapid heating where they can quickly de-ice the aircraft and provide the ice protection in flight. Next application is the catalyst support. So in chemistry, a catalyst support is the material, usually a solid with a high surface area, to which a catalyst is placed. The support may be inert or participate in the catalytic reactions. So current technique versus the CNT method is where the conventional alumina or silicon support are used. So for example, I focus on the fission drop synthesis, where this process needs to be catalyzed by a certain transition method, such as the cobalt and iron, which present the highest activity. So by comparison, the cobalt catalysts are preferred because of its high activity and selectivity to linear hydrocarbon for FDS process, which is they are more stable and low cost among them. But using the carbon nanotubes as the cobalt catalyst support was found to decrease the temperature of cobalt for such species. The strong metal support interaction are reduced greatly and the reducibility of the catalyst improves significantly. They also help to increase the dispersion of metal cluster and thus decreasing the average cobalt cluster size. And finally, the hydrocarbon yield obtained by the CNT supported cobalt catalyst is larger than the conventional technique. Next application is we will focus on the field emission. So field emission is the emission of electrons from the surface of a conductor under the influence of a strong electrostatic field as a result of the tunnel effect. So the field emission is widely used in the field emission gun, which these guns are used in the electron microscope. So current technique versus the CNT method is the conventional cathode ray tube display use a single electron gun, and the CNT based display uses separate electron gun. Even there are many of them are used for each individual pixel in the display. Because of the low turn-on and operating voltage, high current density, and steady long-lived behavior, making the CNT is very attractive field emitter in the application. In addition, their current also extremely stable. So general type of low voltage cold cathode, lighting source, electron microscope source, and lighting arrestor are other applications that utilize the field emission characteristic of CNT. So actually, there are more of CNT applications, such as they are used as a conductive plastic. They also used in energy storage and biomedical application. They also use as a substructural composite. However, in some application, they are still under research. And of course, we still use a regular material to proceed this application. There are some fun facts about the CNT, where actually the CNT this was no the CNT actually is very useful in by creating the space elevator. So NASA and its partner hope that the space elevator could serve as a cost-effective and relatively clean mode of space transportation. This space elevator actually could give the material at just one-fifth the cost of rocket, since the most of rocket energy is used simply to escape the gravity. So finally, the technology could also expand the possibility for the space tourism or even space colonization. So that's all from us. Thank you and Assalamualaikum warahmatullahi wabarakatuh.